So now I'm going to do a problem that's going to require us to do the integration by parts procedure twice. So let's see how this works. So we got two pieces to it, two different functions. We've got the x. We're going to make that our u. E to the x is the exponential, was the last on that list in order to do. And again, that list isn't 100%, but in this case, we're looking okay. So this will be our dv here. So we'll let u equal x squared, derivative of x squared, du is equal to 2x dx. And then we've noted our dv will equal e to the x dx. Well, the integral of e to the x, just e to the x again. All right, so this equals, again, it's u times v, so x squared e to the x, u times v, minus the integral of v, which is e to the x, du, which is 2x dx. Well, we need to do the u substitution again. So let's do it again, or the integration by parts again. So, and for our second part, we're just doing this box here, green box. Our u will equal 2x, which makes our du equal 2. And our dv will be, again, e to the x dx, which we've already determined was just e to the x for v. Let's go back to red here. And now this equals x squared e to the x, and we have a minus of this whole thing. So minus u times v, so 2x e to the x minus the integral of v, which is e to the x, du, which is 2, and this actually should be dx, excuse me. Okay, so now we're going to distribute this negative all the way through. So x squared e to the x minus 2x e to the x, and this will be plus integral of 2 e to the x dx. So we're going to integrate 2ex dx, which is no problem. The 2 comes out. Integral of e to the x dx is just e to the x again, and we need plus some constant c. That will give us what we need. Now, we had to do this procedure twice. As you notice, we start with a higher and higher exponent, so we can do the same thing with x cubed or x to the fourth or x to the fifth, and it's just going to expand out. For each one of those, we're going to need to do one additional integration by parts. But again, let's check this one just to verify that we do get the same answer. Let's try this. Scroll down and check it. We'll scroll back up to verify in a minute. So let's do a check. We'll let y equal x squared e to the x minus 2, 2x e to the x plus 2e to the x plus c. So we're going to take the derivative, y prime. This one, the x squared e to the x will require a product rule. So first times derivative of the second is just e to the x again, plus derivative of the first, which is 2x, and then the second is e to the x. All of this in the parentheses there is a derivative of our first piece. And we have another, so I'm going to minus 2, I'm just going to take the 2 out for now, and take the derivative of x e to the x, so it's first, times derivative of the second, e to the x, plus this derivative of the first, which is 1, times the second. And that's our second part, the x e to the x. And finally, derivative of the 2e to the x is just 2e to the x again, and the derivative of c is 0. So let's distribute everything and see what we can cancel and see what we end up with. We distribute the 2, so minus 2x e to the x minus 2e to the x plus 2e to the x, and we don't need the 0 again. So please note, these two cancel, and these two cancel. So we're left with y prime equaling x squared e to the x. And that was our original. So let's go back up here and verify. There you go, x squared e to the x. So again, our solution here is an antiderivative of what that integral is.